Hey guys, I'm Dan. It's great to be here. Super good to be in New York, DEVMOS. I usually am based in Berlin, and there's a huge Cosmos and Ethereum scene as well. So I see a lot of familiar faces here from other conferences, and yeah, great to connect with you guys in New York as well. I'm here to talk about EVM extensions today. And also show some code, right? We are at a dev-focused conference, so I'm really happy to also see other talks that are kind of more technical. But before we go into this, I'm really curious about a following question. Is there anyone in this room who does not like the EVM? Raise your hand. Okay, we talked about this yesterday. Cool, great. Because I often hear, I love these conversations. Some people think, for example, Solidity is not safe enough. But a follow-up question for me would be, would you agree that there's way more users, liquidity on EVMs compared to the interchain and the Cosmos ecosystem? Maybe raise your hand. Okay, a few more. Great, cool. I like this idea because looking into the markets, you really see, how much traction is there currently, and we have a lot of innovation in the future is happening. And I really love basically all the directions that this space is going into, but I want to really be also realistic and let's make this our advantage. Understanding there's so much liquidity and users in the EVM, so how can we actually put this into the Cosmos ecosystem? And so for me, the reason I want to talk about EVM extensions today is because I believe that the EVM as a standard, as an interface, is actually a huge opportunity to get more adoption, not only in Cosmos space, but also in getting more companies and Web3 businesses into the space. So basically, at Evmos, we've been working on basically building or helping teams build EVMs for their Web3 business. We've been doing this for probably 3 or 4 years, right? We implemented the first EVM in Cosmos with Ethermint. That's when I joined actually the project a long time ago. We built the Evmos L1 chain. It was really hard to find actually product market fit. And now we released the EVM OS. You might have seen this as well. It's a bit more of a new direction where we actually provide the EVM to other teams, also Cosmos teams, to launch their own application-specific EVM chain. There's Ripple, other projects that we've been announcing. And so I think talking about the EVM is in combination with Cosmos is really interesting because we originally chose to stack the Cosmos stack in IBC because of its modularity and the customizability. And we really see a huge benefit for adoption here. So that's why let's get into it. EVM extensions basically are one of the key technologies that we've been building in our stack, and I want to share with you guys. To put it simple, it's basically an interface that allows you to interact with Cosmos core messages, the Cosmos core protocol modules from the EVM. So as a user or as a Solidity smart contract, you have a Solidity interface, and you can kind of bypass the execution layer, or sorry, the EVM execution, and just get into the Go code immediately. You might be familiar with precompiled. It's essentially the same. EVM extension is just a different wording, a different brand. And what they are predefined smart contracts. They're bundled with the EVM. This means you basically have an interface it's a smart contract at a fixed address. You can also decide determine your own custom gas cost. And like I said, you don't really execute this logic on the EVM bytecode, but rather natively on the Cosmos client. So you can actually put the implementation into Go. So any Cosmos core engineer will easily be able to actually use this and still be compatible with the EVM. Also for this talk, I'm just assuming that there's Cosmos core developers in the room, and hopefully you can also see online, and you guys have some knowledge of how the EVM works. So I'm going to give a bit of context, but maybe not go too deep into it. Also, I think understanding why is this useful, what can we use this for? I think it makes sense to look at some use cases. like I said, you can interact with like core messages from the EVM. So one simple case would be actually just adding EVM wallet support for any Cosmos chain, right? We have MetaMask snaps, but it's not really the most durable way of actually doing it. And you could use MetaMask, Grabby, or any EVM wallet to broadcast EVM transactions and then handle this in the core protocol. There's also stack optimizations that we made. So there's, for example, the single token representation, which we've been talking about a lot because this is basically a thing where you have the ERC20 as a very accepted token standard, but we also have the Cosmos Bank module, and we also have token balances there as well. And we actually use EVM extensions to make the interaction between these both balances really smooth. I'll get into that also a bit more later, but that's also helpful with EVM extensions. And last but not least, you might have even used them. So we've built outposts on Osmosis and Stride. So EVM extensions also help with interoperability with IBC. So you could tap into IBC from the EVM and do a cross-chain transfer, for example, on Osmosis, or liquid stake your tokens on Stride currently from Evmos. So this is like one transaction you make on the Evmos network. It also as a smart contract. You tap into IBC, it sends over the token, does that service, either cross-chain swap, liquid stake, whatever, with the hook, and then it just sends back the token, either the liquid stake token or the swap token. And the difference here is that it's really accessible from the smart contracting level. Okay, let's go a bit more into the technical design. You might be familiar with the app.go file. I just want to go kind of like through how you actually initiate or like build a new EVM extension, and then also go through a transaction flow and deal with some like challenges that we actually had on the way building this and iterations. So yeah, you might be familiar with this. So if you want to build a new EVM extension in app.go, you basically set up all your modules, right? You have the keeper. With the EVM, we have this EVM keeper and add to it basically your custom precompiles. If you're familiar with Ethereum, there's a bunch of like standard precompiles that you use. But here you basically just link it up and add your available precompiles that are custom to your chain. You'll be familiar with staking or distribution. So basically you could write a smart contract that uses staking to delegate or to stake your tokens. The distribution module, for example, for just withdrawing them, right? Right, so if we just look at the simple transaction flow, I hope it's big enough, but what basically happens is when you have your EVM, even on the Cosmos chain, you basically have the JSON RPC, right? You just have expose the API for anybody to broadcast transactions, and these are then routed to the message server on the EVM module before it's actually like parsed into a message Ethereum transaction. And then it basically reaches the EVM module and goes to this method. It's called apply transaction. Second step, I guess, or maybe I can stay on this one. Yeah, maybe stay here, because so as soon as it goes to the apply transaction, what happens is basically similar things that happen on Geth, on Go Ethereum. So you instantiate a new EVM, and then basically you add to this EVM your custom precompiles that you've defined. I call this like custom active precompiles because they're also triggerable through governance. So you could just like basically update the chain, but also just activate them at a later point or deactivate them if governance decides to do so. Exactly. So yeah, this is just kind of also showing that we did actually use a fork or like built our own fork to add these precompiles, because there was a difference in where you initiate them, and there's, like I said, these standard precompiles on Ethereum, and you actually want to add your custom ones to it. Exactly. So next step, we initiated or instantiated the new EVM for this call, and then you basically just want to execute the transaction. So what happens here is you go into the call function. This is, again, the Go Ethereum side. It checks basically based on the address that the message is interacting with. Is this a registered precompile? Yes, no. If it is, then it will run the do the if check and run the run precompiled contract transaction method. If it's not, then it's just going to run the EVM interpreter and do like a regular bytecode execution. Right. I think what else is maybe interesting, you also see the gas, like the required gas. Like I said earlier, with your EVM extension, you can also define your own custom like gas method, and yeah, basically deciding how much users or smart contracts need to pay. Right. So where am I? Just give you some. Let me just check where I'm here now. Right. So staying on this one, basically what happens as a last step, if you know, okay, or the protocol knows we're interacting with a precompile, you run the p-run function, and this is where kind of the meat and potatoes lies, right? So here's your business logic. Here's where you actually define all the transactions, the queries that you want to expose from the EVM to yeah, really use the Go code. And what basically happens is it runs the run function. There's a simple switch method to basically decide, okay, is this which method is this? It's the transaction, like maybe, I think this one we have the staking example, so it could be a delegate or withdraw function, for example. And then here's where you really define your custom code. You check a bunch of authorizations and then go into like the business logic. Exactly. That's basically it on a high level. If you want to look into like the actual implementations we've done so far, they're all like on our GitHub. Simple overview of how to build your own EVM extensions. All you need to know about is the precompiled contract interface. As I mentioned, if you comply with this one, you can define your own custom address. If it's stateful, that's just there's some optimizations. If you don't actually change the state, you don't need to like run so much code. The required gas, like I said, and then the run function really defines all the transactions and methods. Simple primer on this, we basically use all the standard Cosmos things for querying and broadcasting transactions. So for queries, we have the Cosmos querier. The only difference is you need to parse into Ethereum responses. And for transactions, you just take the decoded inputs from the message and build your Cosmos message, and then basically call the keeper. That's kind of it. What you should be taking some attention on is you want to also admit events. So we have Cosmos events, but also Ethereum events. These are important for any clients like indexers, whatever, to interact with the chain. So that's kind of it of how you can really implement your own ones. I mentioned there's some problems on the way that we've found. So initially, like precompiled, we thought, okay, they're always predefined, but we noticed, oh, they're not so precompiled after all, because we had some like business cases where we really wanted to initiate precompileds depending on the chain state. Coming back to the single token representation I mentioned earlier, basically what we implemented with this is before, like we had basically two states. We had the bank state where IBC vouchers or IBC tokens balances are, and then if you have a ERC20 contract, that's where the whole the balances of the ERC20 token are stored. And what we did is basically say, okay, why don't we just keep everything on the bank module and then expose an additional interface on the EVM, which is an EVM extension, to interact with this bank state. Not really regarding the ERC20 state anymore. And so what we basically built is that every time a new IBC token arrives at your chain, this automatically registers a new precompile, so that you automatically basically ERC20fy your new IBC token, which can be really powerful. So yeah, like I said, this depends on the chain state, right? The IBC and then bank state. So this is kind of how we also had to, there some challenges in the design that we didn't really think about before, and we had to iterate on. This was really interesting. The second thing is when we talk about this, a lot of times people ask, well, why don't we have a generic message passaging for any module or any method? And what we found is there's too many like custom modules because we work with a lot of different teams, and also we expect, that's the nature of the Cosmos SDK, the Cosmos ecosystem, that everybody has their custom business logic. And we found there's actually more power in building this I guess architecture where you can define anything you want really. So one example we ran into is like the authorization for different modules, even in the Cosmos SDK, are different. One module basically expects that you have like a specific authorization for a specific amount. Another one will say, well, I'm just authorizing generic like interaction with the message. And so yeah, that's why we kind of took this approach of having like custom implementations for each module. One obstacle to solve I wanted to mention is the events. So currently we're actually emitting both Cosmos and Ethereum events, which is kind of it's a decision we haven't really made yet so far, because some teams really want to work with the Cosmos side, others with the Ethereum events, and this can like create like unnecessary state bloat. But this is something like I'd love to talk to you guys about, like whether or not in the future you see one or the other one being more important. Yeah, that's basically it. Thanks for listening. If you have any questions or want to talk to me, I'm in New York for a couple more weeks, usually, and then heading back to Berlin. But yeah, happy to talk to you guys about EVM extensions. Thank you. Any questions? Yes, please.
My question is, have you considered more a purer version of EVM on top of like Common 50 straight away, rather than sort of routing things through Cosmos SDK? Because in my personal experience, like having helped with teams who want to do Cosmos, but then at the same time EVM, is that there's kind of confused between like where to write their custom modules in. Let's say, because like it gives you infinite ability to write whatever in as a custom Cosmos module, but then I slightly sometimes feel like it would have been better if you just wrote like solidity contracts in EVM, which in that case would have been like cleaner for these specific teams to just do everything on EVM side, which at that point Cosmos SDK, the notion of Cosmos SDK is sort of like not much adding like not much value to the entire stack, apart from maybe IBC, which I believe you can do through pre-compiles, especially the with the hacking bank modules, in a way that you can sort of onboard or register the bank state as ERC balance, which is possible because I've done that like in my free time as well. So like I feel like the problem would be that most teams are sort of confused because like there's too many options available. I just wanted to hear on your opinion on that.
Yeah. Great question. I mean, for me, I always come back to this idea of adoption. Like, where do I find most teams and the easiest path? I think implementing things in Go is like a fairly safe way. And a lot of teams that come to us and like talk to us just have this idea like building an L1. Like that's why I had this picture in the beginning, the meme, like, or like this monolith, like building a L1 with a standard Cosmos stack and put the EVM on top of it. It just seems very simple, to be honest. Yeah. And yeah, whether or not you want to build your product on, as a Solidity smart contract or on the Go level, I mean, I wouldn't say I'm very opinionated on it, but I've just seen like most of our conversations we've had in the last year in particular, where we really opened up this idea of using our EVM to other teams has been always, they've already built some Go modules or something. Yeah. And the EVM or like the Solidity layer is more like for community building and easy integration of clients or any other existing tooling, right? So when we work, for example, with like a gaming company, they just want their primitives on the Go, like core modules. There's a lot of flexibility you can have. Yeah. And then, yeah, like I said, the Solidity part is maybe more in the community and compatibility side, and also regulation.
Makes sense. Yep. Thank you.
Yeah, I mean, I'll second that. I mean, we've been, Osmosis team has been talking to the EVMS OS team for a while about like adding these, and for us, it's like, all of our logic is in the Cosmos SDK and CosmWasm, but we would like to have the EVM there primarily for the single token representation. So like, it's easy for like a MetaMask wallet to just like integrate and like all of your Cosmos tokens show up as like ERC20 tokens and stuff.
Yeah. Yeah, I mean, I'm really excited about everything else as well. Like the whole like direction and modularity I find in this space is incredibly important. But I'm also trying to be realistic in a way and see, okay, from a product perspective, like what are people needing now, right? Even if it's not the most scalable system, I find we try to do like partnerships and use cases of how to transition or migrate from the current system to a more scalable one maybe in the future.
I have a question.
Yes, please.
The default, why, like you were saying that there's all these custom, you said that you had to make your own sort of custom template for all these things. So I guess my question is there like a fallback? Is there like a default fallback that all chains, I guess, could, instead of having them to customize for Evmos, is there already like a default template that they already resort to? Is that, or is that not? See.
So you mean like default precompiles, or?
I think like some equivalent of like Stargate message in CosmWasm.
Yeah.
Being like the custom like thing, like it's just like okay, there's just like one precompile that just calls any arbitrary Cosmos message.
I mean, that was the example for this general message passing. What I was explaining. Maybe that's what you're referring to. So we don't have a like auto-generated precompile that just whitelists any message. We could probably build this, but my experience so far has been that it's I guess more safe and like more beneficial because there's always custom logic involved. But it's a good point. Like it's something we also considered, but we just dedicated the time to more custom implementations. And then, like the beauty of the Cosmos SDK or like just modules is that you can share them, right? And things like staking, IBC, governance, like these are all things you kind of get out the box, including the precompiles that are like on the like Geth forks. Yeah.
So I guess my only is so people are gravitating this. Are you finding it that working? That's successful, as having these custom templates versus having like another like an option that people are already sort of used to, I guess.
So far, yes. I mean, yeah. So far, the teams have been using this. Yeah.
Are you guys working on something similar to like Beaker or like which like generate like we have like it takes Cosmos SDK messages and generates the CosmWasm types for it. Do you have something that's going to take like Cosmos SDK messages and generate Solidity types?
What do you mean by Solidity types? Like the ABI, like the interface, or?
Yeah, because right now, like when you want to like call precompiles in the EVM, you have to like call a static call and pass in that whole ABI. So like it'd be nice if we could generate the ABIs. I
mean, there's like tooling to create the ABIs. I think I even maybe did I have it actually here? It's kind of cut off, but we built a little tooling like to compile the ABI from the messages. Yes, that's what you mean.
Yeah.
So yeah, basically you still need to. It's the same way of interacting with any EVM. Like you still need to use an ABI, right, to actually broadcast the transactions. Yeah.
Cool. Other questions?
Awesome.
All right.
Thank you so much. Cheers.